get started here. Can everybody hear me okay? Awesome. My name is Marty Stratton. I'm the executive producer of Doom at id Software. Welcome to Uncapped, Doom and the Power of id Tech 6. Thank you for being here. I think this is our first panel of QuakeCon, so really appreciate you being here, being at QuakeCon and coming to this panel. As people were walking in, I actually noticed a bunch of id people as well. So actually, I want to start off by maybe having the team that came to see this. I know everybody hopefully loves Doom and has had a lot of fun, but there's a lot of guys. If you're standing, wave your hand. If you're sitting, maybe stand up and say congratulations to the team. We have a great team at id, and it's fun for us to get up and be able to represent the team in this fashion. So I know everybody is here is probably very technical, really into the technical bits of gaming and technology and hardware. So we'll get into a really good deep dive on that stuff. But actually, before we get started on that, I'd like to just kind of maybe start at the end there with Robert and have you guys go down and just introduce yourself. Tell us a little bit about what you do, and maybe give a little bit of now that we're done with the project, a little kind of anecdote of maybe something your favorite thing that we accomplished or that you accomplished, particularly related to the tech.
I'm Robert Duffy. I'm the CEO, or not CEO. Off on.
Sometimes he thinks he's the CEO.
Sometimes I do.
Is it working?
Is his microphone on?
Light should
No.
There we go. I'm Robert Duffy. I'm the CTO at id. I've been at id for about 17 years, I think. Long time, and I think probably on this project, what I enjoyed the most, and I think what I'm proudest of, was just how the entire team, both from a technology standpoint and a creative standpoint, worked together and produced what we felt was a really, really good, solid game. Performance is a cornerstone of what we do. But performance takes both technology and, it's a team effort. It's not just a bunch of programmers making stuff go fast. So I think the way we came together, run at these super fast frame rates, that's what did it for me.
Uncapped frame rate.
Uncapped.
Hi guys. My name is Shell Williams. I'm the technical specialist at id. The thing that I'm most proud of is when we had the E3 Doom gameplay reveal, and I was given these two maps to play, and I had to figure out the best way to show everything about Doom in those two maps to the whole world. And probably what I'm more proud of, other than playing those, was when we got back to the office after E3, the whole team was diving into the web forums and online and reading comments from fans, and we took those suggestions and we implemented and tweaked the game to put that into final gameplay. So it was cool.
Yeah.
Does this work?
Don't worry about managing. Just
That's
turn
right. Hi, I'm. Wow, that's pretty loud. Hi guys, I'm Billy Khan. I'm the lead project programmer on Doom and id Tech 6, and I think the most impressive or most thing I'm most proud of is we really enjoy making GPUs melt. So, and what I mean by that is we tried to really push the boundaries on all the platforms that we shipped on. We wanted to make sure that we really, we didn't sacrifice either putting lower quality on one platform. We really tried to push each platform to its fullest and make sure that it ran as best as it could with the highest fidelity visuals that we could make. And what we ended up with is something that's usually unheard of. We really make full usage of the GPU almost 99-100% of the time, and we're ALU bound, which is something that is very uncommon when we make games. Usually most games are bandwidth bound. So when people talk on the forums and say, "Oh, my PS4 or my PC's the fans are going crazy," we actually think that's very cool, because what it means is there's no latency. The GPU is really used the entire time. And one other thing, I think, if you noticed our progression from our first reveal in QuakeCon 14 that was behind doors for you guys, if you look back at all the stuff we presented each time as we progressed, we've made leaps and bound improvements as far as performance and visuals and just general improvements based on feedback from the reaction from the crowd, as well as we played the game. So I think Even now, I mean, even post-ship, if you look at the stuff that's now coming out of DLC, the visuals that we were able to push on the new maps, or even the stuff that we just did with Vulkan, I think we continuously try to push the boundaries.
Hi everybody, my name is Thiago Souza. I'm the lead render programmer. So essentially what that means, I essentially just make pretty pixels, in a sense.
Really pretty pixels.
And fast, of course. So they need to run fast on every GPU and hardware configuration that we try to aim for. So the thing I'm mostly proud of is that I would say how quick we iterated. So I would say most of the engine stuff, the render side, was like done in less than 2 years. So that's actually a big achievement in my particular point of view. So having to refactor a ton of things so that everything looks as nice as possible and still runs at 60 Hz or even higher frame rates. And in the end, also like assembling a new team in a way. So a lot of the rendering technology and the rendering team was assembled during these 2 years. So I think that's fairly impressive, I have to say, particularly given my past almost 15 years of experience on the industry. So that's it.
Yeah, I think you hit on something there. Like we did assemble a team kind of over the course of development. We kind of iterated on the tech very, very quickly. We have very talented people with lots of different experiences and ways of looking at things. One thing I'm always asked about on the creative side is kind of managing the vision of the game and the creativity. How do you keep a focus on that? What would maybe starting with Robert or Billy here, how would you characterize kind of the vision for IdTech 6 as we developed it, and was that, do you feel like that's different? I mean, Robert, you've been here a long time, so do you feel like that's different than past technologies that we've done?
Yeah, it definitely has been. I think the historically at id, we've kind of built a technology and then we designed a game around that technology, and this time around we really wanted to we knew what kind of a Doom game we wanted to make, and we really worked hard to work on getting the teams to work together and building the technology around kind of we knew we wanted dynamic lighting back and a lot of dynamics in the world from a rendering perspective. But our key goal has always been at least 60 hertz. We wanted to do better visuals than other games are doing at 30 hertz. Generally speaking, I think we've succeeded in these goals, and but it really is about player movement is key for us, and you've got to be at 60 hertz to get the kind of feel you get from an id game. And I think just a marriage of the tech and the creative process has been big.
Billy, as far as your perspective, you've also been here through the development of most of IdTech 5 and seen that. How would you again, when you get people coming together from very disparate backgrounds, you want to try to have that common goal for you and leading the team as well. What are kind of the things that you preach and the approach that you take?
I think we have to stay true to what we've always done at id Software is we try to push the boundaries. And one of the things that we did really well on this project, I think, is have that relationship that Duffy was talking about, which is that symbiotic relationship between art and design and programming, and making tech that really makes the game stand out. Not just make a tech demo and then make the game afterwards, but this time we looked at what we felt was a Doom game in current modern times, and we really want to bring that to life. Bring that comic book style, high visual, high fast-paced action to the forefront with amazing graphics, and then and big portion of that is also full going really fast from a rendering standpoint. So. But you can't do that just in tech. So, sometimes you just, you make content and then you try to optimize it. I think the approach we took this time, which was, we got art involved, we got design involved, we got the tech group involved, and we really sat down and said, what are the things that we need to focus on may it be the gore system, may it be the melee system, may it be, pathing, or even how's the guy look like when he explodes? Like, what kind of particles do you want on the screen for that? Making sure that we had all the necessary tools available, so the content creators and the design team and the artists could really realize the vision in their head, but make it run super, super fast. Because when you have a game that runs super, super fast, it takes it to the next level. It's something you have to feel. I'm sure a lot of you guys are probably playing on 144 hertz monitors out there, and that's very important to us. So having the group of all the parts of the development team working together was crucial, because we asked the artists multiple times to redo the textures. We asked the artists to optimize their meshes. We asked the artists to think about how, we asked the designers to think about their, how the gameplay would work out. So I think the biggest thing was having that close communication loop and working together that really stood out, as well as having an awesome team.
I was on vacation last week, and I read a book that Eric Carell, our marketing manager, recommended, called Go Like Hell. It's about, like, back in the early 60s, the race between Ford and Ferrari to win the Tour Le Mans in France, I guess. And it reminded me so much of, like, when you read about, like, the way Ferrari approached their development, or even Ford to a certain extent, but a little bit more so Ferrari, because it's very boutique. It reminded me so much of kind of like what you guys do from a just pushing the envelope perspective. Thiago joined us about 2 years ago or so. 2 years ago. And you came from Crytek, slightly larger. How has things, from a day-to-day perspective for you, how do you approach being at id? Has jumping in and, like you said, really transforming the renderer over a couple of years? Kind of what was your day-to-day like, and kind of the pressures, or even just the opportunities that you felt once you landed here?
Essentially, we started by evaluating what we had at that point. I started by evaluating all of the technology and all of the code, and okay, what can we improve, especially for the art team? How can they work faster? How can they achieve nicer visuals in a more consistent way without having to redo assets so often? Although, with the change for PBR, of course, they had to learn a lot in the process to make assets in a consistent way, essentially. Then it was also trying to help designing the technology so that, for example, on the tool side, it would be more efficient for the art team to, let's say, detail the worlds, or try to achieve nicer and consistent results more easily, instead of having to wait, I don't know, like 8 hours until they can iterate on something. So essentially, the workflow, it's key for achieving visuals. Then there's, of course, the more geeky part of it. So how do we design something so that it runs, so that we achieve this nice quality and performance ratio? So you cannot just go to one end and just make everything running super pretty and super, let's say, very technology heavy, because then you have a kind of a slideshow in the end. Okay. And then you can also just go for performance, and then everything runs super fast, but then it looks not so interesting. So it needs to be a balance of such kind of things. And that, has several implications. So it's not just, of course, code as creates the foundations so that the art team can achieve their own vision. So things like lightning, having a nice color reproduction, so on, tone mapping and stuff like that. And there was a huge amount of catch-up, let's say, like this, so that we can reach this kind of next-gen visuals across all of the platforms that we have to support in an efficient way. So at 6 Hertz, which is actually even more than 6 Hertz. So yeah.
You mentioned the transition to PBR rendering. I'm sure everybody knows what that is to some extent, but that was a massive step in the course of development. One of those moments of like, oh my God, that the game went from hey, that looks pretty. It was actually it was right after QuakeCon 2014. I think that we made that leap, and that was kind of like that first big step from IdTech 5 to IdTech 6. Talk a little bit about kind of the decision to do that, and even so kind of the why, and then the ramifications, because we did end up, I know we have some artists here that did have to go back and redo a lot of stuff. What, maybe again, Billy and Robert, you can address that.
Well, the goal to go to PBR was, it was not only to make it look much better and more realistic, it's also to make it easier for the artists to have consistent results. Going physically based allows us to ensure, for the most part, that the art that the artist creates does not have to be baked for a certain situation. So it looks always good within a certain lighting scheme across all maps. Prior to going PBR, many times you would have to tweak your art specifically for a certain level, and then you spend a lot of time, and then consistency is a problem. So PBR. At the first, there's a nice switch to that. There's some learning curve there, but once you understand the fundamentals, I think it actually speeds up production and also allows us to make much more and focus on what's important, making kick-ass art and making the game awesome. One of the stumbles that we had is we also, on top of that, we wanted to go, we wanted to gamma correct our art pipeline, and to do that, it was painful because traditionally, that means calibrating your monitors, making sure, everything is solid and it looks right, but that takes a steep learning curve. We actually had some stumbles of that where we tried to gamma correct too many things, and looking back at that was probably a mistake, but the artist stuck through it and redid the textures multiple times for us. And I think, props to Lear and the guys to really hang in there and stick with us, because I think the end result really shows that making that choice was the right choice. And we need to have dynamic lights. Doom requires dynamic lighting. It requires the world to be full of blood and looking nasty, and we really need specularity in our surfaces. We need to be able to show the sheen, and the Mars station, for example, it requires a lot of metallic. So going with GGX for our BRDF was a natural choice. What do you think, Duffy?
I think the artist hoped that we avoid the time when they redid all the textures. And then about 2 days later, we were like, hey, guys, there was this bug, and you're going to have to do all that one more time. So
We have very, very nice, understanding artists who worked a lot of overtime. So same thing.
I can also elaborate a little bit more on that side. So, PBR there's a lot of course, mathematical foundation. So making sure everything's proper from a code perspective. But also for the art side, I think it's a really nice workflow for them. So instead of each artist making their own little texture in vacuum, working with their own little style, that's good in a sense. If every artist works that way with their own little style and different, let's say, texture inputs, you end up with this big soup of results and inconsistency. So from a physical perspective, essentially, I see it as a workflow for the art team to work in a consistent manner. So they create textures, let's say, they paint how does metal behave, how does plastic behave, how does blood behave. So essentially, all of this is driven by a physical, let's say, a physical approach, and not just a random, okay, maybe this is that color, that color. So it's much more easy, I think, for the art team in the end. So.
Yeah, definitely. It was a kind of a stunning turn for us. Shale, I think you're kind of interesting because, and you're probably actually a lot like a lot of maybe some people in this room, where you're technical, very interested in tech, very analytical, but not necessarily a programmer, by background. It gives you a kind of this, and you've been at the company a long time. You've worked with Robert a long time. And you've kind of taken on this role of part analyst, part firefighter, part problem solver. You'll kind of dig in when honestly a lot of people can't figure out a bug. You've been around long enough and understand the technology well enough to dive in and find it. What does Dynamic lighting, right there at work.
It's running faster now.
We just went up 20 frames per second. So anyway, what does kind of and a lot of that always happens right around the times of demos. You mentioned E3. QuakeCon was another one of those where, for us, like the rubber really meets the road. Certainly the last several months of the project. What was kind of like a day like or a week like in the heat of that battle when you're kind of a backstop a lot for the tech team and the team in general?
So it usually gets pretty crazy. It's hard for me because sometimes I don't know exactly what to do, but I know who can do it if I can't. But as a background, I got a BFA in animation, and then after I graduated, I got a job at id as QA, and I got my foot in the door. And after that, I just started being really, really good at just narrowing down issues to like even lines of code. And then I started working for Duffy and started digging in the systems and figuring things out myself. And then I kind of learned like general coding a little bit. And pretty much now, anytime anybody has a problem, they come to me and I can figure it out. Almost everything, but again, if I can't, then
Sometimes Duffy comes to you because he doesn't know how to figure something out. And you figure it out.
That's true.
That's true.
So I actually want to talk a little bit about, speaking of figuring things out, it's amazing. I want to talk about optimization because I don't know if you're a programmer, you probably understand the value of it, but I think it's an underrated part of development, and I think people would if you're kind of wondering how things get to where they get from a frame rate perspective, it's a pretty important part of that. But taking one step higher level than that, it's still, I've been in the industry 20 years and it still baffles me the way gaming software runs and how complex it is and how much is going on. Todd Howard once had Guy Carver, who's the lead programmer at BGS, do a talk for their team about like what happens in a single frame of the game. And when you think about that relative to watching a Pixar movie or something like that, and you know a frame of that movie is rendered over the course of a day or something like that, and we're doing 60, 80, 90, 100 frames a second with the player in full control at not that less of a visual quality, if at all. I thought maybe, again, you could do a whole talk on this one thing, but maybe Billy, you could kind of just explain kind of what happens in a game or rendering frame for everybody, and then we can talk about how that runs fast.
I have a short answer, way too much.
That is true.
Yes, a lot. And I don't know if you guys can hear us.
We'll talk loud.
Yes. So you have the CPU, you have the GPU. Traditionally in Nitec 5, what we had on the CPU, you would have two threads. You would have the game logic running on one thread, and then you have the render thread running on another one. And what that means is the game runs, the game logic runs, the AI logic runs, and so on and so on. And then after that's done, you then sync that with the render thread, and the render thread then decides what needs to be displayed on the screen, and then you present that to the GPU. But that's just a really high level view. We changed that around. We started thinking like we don't want to just do that with one thread, so we broke it down into so that all the command buffers, what we call them, basically thinking of like recipes for different sections of things that need to be rendered. We started accumulating and generate them on jobs. So we have asynchronously bunch of threads that create all these different little lists of things that need to be done, and then at the end we then in order sent them to the GPU. And so if I were to break down one frame, you have things like, you have to figure out what needs to be displayed. And you have, what are the things that cast shadows? Then you have to what can we call, then we need to sort things. And the way we sort things is we start off by sorting them by shaders, we call them render progs in that software. And then after that, the next step, once if you have something that's equal, same shader, then we make sure that it's done, based on depth, and then we have another heuristic. So we have things sorted in a certain way, so as things get occluded, then we don't pay the cost of rendering them. And the way we accomplish that, one of the ways we do that is obviously call them on the GPU, we call them on the CPU, but we do things like a very common technique is we would do a pre-Z pass. And that basically allows us to know all the pixels that basically records where that pixel resides in the world in the Z value. And what that allows us to do, it allows the GPU to reject pixels that are obscured. That's one thing. There are lots of other things. Shadows have to be rendered, so we render meshes and surfaces from the viewpoint of the lights and create our shadow maps. Once you have that done, then you have to render opaque things that you can't see through, and that's where all the magic happens. We have most of the surfaces that we have, most of the meshes that we render are opaque surfaces, like the world, and let's say I would model like this card or whatever. And we have a unified shading model, and so we do all of our lighting and shading and decaling is all happening in this pass. So this has to be super fast. We use a clustered lighting approach, and Tiago worked on that. He can go to more depth about that later on. But that's where most of the magic happens. We have an opaque pass where we do our shading, lighting, and the decals. Traditionally, we've done by baking them into something called a megatexture, but we now do them dynamically, and this happens all on the same pass. And then, of course, after that, we have deferred passes for some of our special effects, like SSDO. Then we have SSR, which are screen space reflections. We have accumulation of of our probes, our light probes, and then we decouple. We have a light atlas, so we can decouple lighting for our particles, for example. But most importantly, as you look at all this stuff, there's so much stuff going on. We have to make sure that we optimize that. So it's not only just optimizing, sending it to the GPU, we also have to micro-optimize each of the shaders and making sure that we don't constantly have tons of shaders. You want to unify that in as least amount of shaders as possible so we can avoid context rolls and, worry about fill rate cost with your post-processing steps, the places where we tone map the PBR scene and so on and so on. So there's a ton of stuff going on, and one of the biggest gains we got was going asynchronous, because we saved a ton of time on the CPU, and that way we could make sure the GPU was never stalling, and we made sure that the GPU is always busy, and it's almost like a jigsaw puzzle. You profile, you look at the scene, and you're like, okay, well, there's a gap there where nothing happens. How can we fill that gap? Let's move this stuff around, and you keep iterating over and over. It's trivializing some of the hard work we've done, but if you think about it, it's really just taking a bunch of pieces and trying to fill in the gaps. What are your thoughts?
Essentially that's about it. It's all also from a different perspective. It's like how you design the solutions for, let's say, the shadows, for example. It's not just about rendering shadows. How do you make them fast and not spending 20 milliseconds just rendering shadows and stuff like this? So actually, our shadows are fairly efficient, and some of the details in there. We try to cache things, so essentially we don't like to repeat the work. Essentially, whenever you start repeating work every frame, there's a key, kind of a hint in there that you are doing something stupid. There's maybe this can be actually improved, the algorithm and the design of the things. Maybe we can decouple the costs, the frequency of the computations. That applies to several things. So for example, we were talking about the particles. Particles is a very good example of a performance hog in a video game. Especially if you try to think about as we go higher and higher resolutions, the amount of pixels you have to rasterize for particles, it's goes insane, the amount of computations that you have to do on a per pixel basis. So the solution there was, for example, on the algorithmical side was, how can we decouple the frequency of computation for the particle lighting? And if you look at particles, they generally look blurry in a sense. So why are we doing this on a per pixel basis or on a different space? It's kind of stupid work. So So the idea there was, maybe we can just render like one little quad per particle, and we just accumulate all of these lightning into a little atlas, and then we essentially are caching the results in there, so that we use this kind of stuff. And of course, that's a couple of orders of magnitude, and it's decoupled from screen resolution, and so on and so on.
Could you speak up, please?
Sorry.
I'm sorry.
Do we need to like turn these back on or
No,
something?
they're working on it.
Okay.
There's a problem. So you guys just have to speak really loud.
We'll cut the bottoms out of these cups. And be like, "Whoa."
Yeah, but essentially it's about the design of the things.
Right.
It's not just about we have to implement this. It's how you design it so that everything works properly. And I'm not a fan of complexity. I like to keep things as simple as possible. So it's also about designing technology so that everything works nicely together in the end, and not having, we are doing something special for the opaque rasterization and something special for transparent, and so on. So there's essentially we could be here talking for 1 month on such kind of things. I mean, if you guys want to learn more about such kind of stuff, we were at SIGGRAPH last week. If you guys want to go super geeky, we are talking about that kind of stuff.
So all of that kind of like 2 or 3 months before the game launches is like it's a bunch of stuff that's kind of all been jammed together, and that is really where the optimization comes in. I think people don't talk about it often because it's like talking about your really messy house over the course of a dinner party. Everybody's like, "Oh, your house is beautiful. You should have seen it before you came. It looked like a crap hole." But it is really this kind of from an outsider's perspective, somebody who isn't an engineer, it almost looks a little bit like magic when you guys are running the tools. Maybe talk a little. I mean, you and John were kind of leading the charge on that stuff. Maybe talk a little bit about how you approach that, because it's like this. It seems from the outside like this big jigsaw puzzle that you kind of have to solve. How do you approach it? What are the kind of tools that you use? What did you guys learn over the course of going from something running much slower than it did once we launched?
Well, it starts. First, you have to understand your problem before you can solve it. So, I mean, we have awesome engineers. Like one of our engineers, Bosley, actually made a cool tool called Remo, and what that does is basically just captures and tracks the milliseconds it takes for all the different pieces of the rendering pipeline, and then we made a little pretty graph, and then everybody that can look at that as people play through the game. And it accumulates all that data, and at the end of we can have reports out and say, when we played Lazarus, the frame rate tanked in this spot, and you can really track whether you're progressing. So that's a high level view. Everybody has a good understanding what's happening. We even had the same tool basically broke it down to like, okay, this is happening in the game loop, this is happening on the rendering side of things, this is what the GPU is doing. And having those easy digestible graphs allowed everybody to speak the same language. So that's from a high level. From a lower level, we basically just had to then analyze. We had to first give ourselves budgets, right? We want to spend this amount of time for shadows and this much of a time for post-processing, and so on and so on. And since you only have like about 16.67 milliseconds for 60 hertz, we basically bucketized the amount of work we need to do into just amount of time we wanted to spend on those things, and how important they were. And then we looked at whether there were latencies, and what that means, little gaps. Like, is the GPU always running at full speed? Is there something that is happening? Why is this stalling now? Like, why is something on the game side preventing, or on the rendering on the CPU side preventing the GPU from progressing? And what you want to do is you basically fill those gaps. You want to reduce the latency, and the way you do that is you have to have code that is very clean and very simple, so you can shuffle things around. It's very important as a programming team to have strict standards on, and this is like philosophical again, but you have to have strict standards, and you have a very diligent programming team to make sure the code stays clean, so you don't over-engineer things. Over-engineering is a big problem with, I don't want to, there's this thing on the internet where people are like, I don't want to code, I want to make everything data-driven, and really what you need to do is you need to solve the problem you have at hand, because later on we need to add something. You just add that extra thing, because the more over-engineered it is, the harder it is for us to rip apart and then make faster. So it starts at the top with having a very, very diligent programming team, having strict standards, but then also giving yourself budgets, having awesome tools. And then you just have to look at from an algorithmic standpoint, like Thiago was saying, you have to see like, what are the problem sets? What does the game need? We need a lot of Doom. We need tons of particles. So we looked at, like Thiago described, we looked at how can we reduce the cost on overdraw. How can we make them still lit, like and still have them look awesome without having sacrificing speed. So. You start off algorithmically. Once you exhaust all those avenues because you either run out of time or or there aren't any better solutions or you haven't come up with that, then you start thinking. You take the problem set and you sit it on its side. You basically say like, what if I break it down over multiple frames? And that's what Thiago was also mentioning, where we do things over, where we temporarily accumulate things over. Data across multiple frames and then break down the problem set that way. And then, for the current frame, we use some data from the previous frame. It's a very fun task. It's profile. It's you take a capture of what the game. You basically play the game. You get a scene that's slow. You take a capture, and then we can see exactly in the profiling tools that you have on the consoles or even on the PC with RenderDoc. You can see exactly what the graphic cards are doing, and we're back.
Hey.
And you will see.
Thank you.
Yay, tech guys! Woo! You have to really make sure that you spend your time wisely, because if you optimize something, the only way you know that is by profiling, gathering data, evaluating, and then testing, making sure that whatever you did is actually making forward momentum. Because like many times you make a change and sometimes if you don't have the proper data, you have to prove that what you did actually made it faster, especially when you talk about something that happens asynchronously, because you could make a change in a job, or you can shuffle jobs around and you actually introduce bubbles or latencies that could slow things down. So it is something that just takes diligence and a lot of understanding from the artists.
And then when all else fails, we use what we call duff tape, which
yes, Duffy comes in like a
named
ninja.
after Robert Duffy. Robert's been at the company a long time, and he just it's crazy sometimes the the holes that get patched by duff tape. But actually, it's kind of a natural, talking about optimization and that stuff. It's a good progression as we also talk about Vulkan. Hopefully everybody played Vulkan. You like the results. We were one of the first, and hope you're enjoying the benefits of that. For anybody who doesn't know, or I've actually had people ask me in interviews, I don't get a very good explanation about what Vulkan is. I hear it, it's a cool word, but I really don't know. That's people in the press as well that have asked that. Robert, I mean, just even for the people who are watching on the stream, what is the most important thing for us is consumer benefit. So what do you like? Break it down just from a consumer benefit to start.
I mean, I've described Vulkan a couple of times at the NVIDIA event and a few other places. I mean, you can look at it like a spiritual successor to OpenGL, but it's definitely not OpenGL. It's a modern graphics API. To consumers, it means you're going to get a better experience from the game, and that's really why we decided to do it. And we decided really late in the project, 6-8 weeks from ship. I told Marty, I was like, hey, I think we're going to go ahead and go for Vulkan, and he was like, are you insane? And but he understood the benefits.
And I said okay.
And he said okay. Yeah. That was the second thing out of his mouth. Id pioneered the use of OpenGL for gaming back in the 90s, and I really thought it would be. I thought it had merit for us to pioneer this again with this new API and really go for it. And I didn't do any of the work. I just so I still actively code, but I mostly do things like I'm good at shipping. At the end and do the non-glamorous resource management type stuff. But Axel had gotten us up kind of to console rendering, not PS4, Xbox console, but our console rendering maybe late last year, and he and Billy were talking about it, and I came in on a Monday, and Axel goes, "Oh, I know. I talked to Billy. He said you don't want to do it. It's too much work." I was like, "No, I had some wine last night and was thinking, hey, we pioneered OpenGL. Let's do it again." And then it was a mad dash by Axel, Billy, and all the guys to get it in, and the results are fantastic.
Yeah. We got a chance to show it off at an NVIDIA event and also an AMD event, and man, looking at it on that Polaris card was just like
200
awesome.
frames per
or
second.
the
It's pretty
1080.
amazing.
Yeah, I mean when we went down to Austin and showed it on the 1080, maybe like outside of obviously the frame rates, which everybody benefits from on Doom, what are some of the other benefits of Vulkan? I know VR is definitely. I mean, it's a big part of that, but Tiago, Billy, what do you guys feel like outside of just the frame rates? Are there architectural benefits, coding benefits that you feel really make it a kind of a strong successor for how we move the tech forward?
I mean, again, it all goes down again to this decoupling of costs, the frequency of costs of what you are doing on a per frame basis. So the old style APIs, for example, OpenGL or the X11 and below. So it's, I'm trying to explain it simply, so bear with me. So you can think of it as, we are preparing to render these objects. We set up some render states, as we call it. We set up textures, etc., etc. And then on the next frame, you do exactly the same thing, and that's completely stupid. So, so the idea is really, we know already all of the states. Why are we redoing this over and over again? We can just precompile all of that state management stuff and reuse all of that stuff. So it's a lot of design smartness in a sense to mitigate all of the CPU side costs in a way.
If I were to describe it as like, think of a sandwich.
I used your analogy earlier when that person asked me. I'm like, think of a sandwich.
Right.
I came up with this, but it's his analogy, so.
So you have a sandwich, it's like a hamburger, right? On the bottom you have like the OS, and then the middle part is huge, and that's your driver. That's what we used to have on the PC side, and then on the top is like your really thin engine. On other platforms like the consoles, that thing in the middle is much thinner. And Vulkan allows you to get that driver thing out of the way. You want to get closer to the hardware, you want to get closer to get beyond what the operating system wants to do. So by removing that thick driver layer or flattening it out and putting some of that ownership into the application or the game, it empowers the team to just code exactly to what the capabilities of the hardware, and because the driver has to work for most other titles, and a driver team may not know exactly what the intent of the application is. So by giving that responsibility to the application or the engine of the game developer, since we know what we're trying to accomplish, we can exactly tell the GPU what it needs to do, rather than the driver has to I don't know what they actually want to do, but I think what they need to do, and then you have all this branchy, slow code that goes in there and has to make assumptions, rather than, so the driver layer really slows down the CPU. You can't submit work to the GPU fast enough. So Vulkan removes that and puts ownership to the game developers, and that's awesome because it allows us to really code, as you guys would say, code to the metal, and allows us to really take advantage of the hardware that's available on the PC, which the PC has awesome hardware. We want to actually make good use of that. Vulkan also has the extensibility factor that OpenGL pioneered. It allows us to request features that as new hardware comes out and immediately use them, or we can even say we really think that this software thing is great. Can you guys do NVIDIA guys and the AMD? Can you implement this feature and give us this information, or allow us to do this specific thing, and then they can expose it to us, and then we can immediately take advantage of that, which allows us to have that really close relationship with our partners. And it allows us to really push the envelope and making use of the hardware again. So having the extensibility is great. That's something that was brought forward from OpenGL. One other thing is it's cross-platform. if you're a developer and you want to make a title, if you support Vulkan, you know, it'll work on mobile platforms because it was designed with mobile in hand. It also works on all Windows platforms, and you know that it's going to be brutally fast because again you're working towards one API rather than having to fragment yourself and having to support multiple APIs. You can focus on what's important, which is the title. So going forward, we hope that more developers embrace this, because I think it's better for the industry and for gamers as a whole. But from the end consumer's point of view, you just get faster games. I mean, literally more stable games, and that's what we all want, right? We want more stable games, faster games, more exquisite games, and then really make usage of the hardware. I want to give some shout out to some of our friends and our partners that really made this happen. I think. You know, at NVIDIA, Matthias Schott and Jean Petelier and, you know, Jeff Boltz and, you know, Eric Reichley on the NVIDIA side. And then on an AMD side, I want to say, you know, thank you to Timothy Lotz and, you know, Graham Sellers and Neil Monday, who have really helped us on the driver's side, because since we're one of the first AAA titles to use Vulkan, we used the API to almost to exactly how it was supposed to be used, and we encountered things and they helped us work through those issues, and that's why we were able to achieve those really high frame rates now that you guys can enjoy.
It was funny. We had moments towards the end of the development where we actually had our engineers and AMD and NVIDIA all like in the same office. We were kind of like, this is weird. You actually tweeted out a picture of everybody at lunch together. It was like the UN.
I have to say, like in 15 years, I never see that kind of stuff happening before. So it was kind of quite cool.
It was awesome. Yeah, really cool. And thanks to them again. I do want to reserve like the last 10 minutes or so for anybody who has any questions. So if we got just a couple minutes, I have another thing I want to talk about. But if you have a question, maybe like come like line up along that wall or in the middle aisle or something, and we'll get to you right after this. I mentioned Vulkan. Is it related to VR? Has anybody gotten a chance to try the VR stuff over Doom VR? Okay, a few of you. Awesome. If you haven't, I would definitely stop by and try it. If you know, it's crazy to have played Doom and then step into a VR experience and see that stuff like right in front of you. You know, as Robert mentioned, Shale's been working heavily on it with a small team over the course of a while here, and Robert's been heading it up. You know, maybe you guys could just tell us a little bit about why it's such a natural progression for the tech and the game, and some of talk a little bit about some of the changes even that have had to go into making that transition and kind of where we're headed.
The IdTech 6, I think, is uniquely set up, uniquely prepared for VR because it is so fast, and kind of 90 hertz is the minimum entry point for a good VR experience, and so having the technology base that we have puts us in a really good position for that. We had, introduced modern VR in 2012 with the Doom 3 BFG demo, and I look at these next steps as evolutions of that technology and evolutions of our brands. I think Doom is particularly well suited as a brand, just because I love Doom, and being the Doom Marine might not necessarily be the best angle for VR, although we're working on figuring that out. But what we're working on right now is really game design principles that we can apply to not only Doom but other Bethesda brands over time, and try to figure out how do we build compelling worlds that can sit alongside the first-person shooter experiences and really showcase the UAC, showcase the Doom world, showcase Fallout and Skyrim and everything like that, and just look at our brands from a company.
Well, yeah, Shale, you and Mark, another one of our programmers, you guys have been doing a ton of work on it. It's a good example of where, kind of a programmer and a technical specialist get to even participate in the design of something. What are some of the things that you feel like we've really had to change from a or even like I played the VR experience here and had played it at E3, and you guys had evolved it quite a bit even since then. You know, what are some of those things that are really pushing it to make it more and more fun every day?
Well, a lot of the things are just, I get with Mark, the programmer, and we just talk about what we could do to make it better, and we just try things, and we keep trying them, and basically when we find something that kind of works, I will think of something that would make it cool, and we just try that too, and it's been really a whole lot of like trial and error. Like a bunch of the stuff we've tried, it doesn't work, and particularly to movement, I hear a lot of, oh, I don't like teleportation, but I've tried the D-pad movement. I've tried moving like in other ways. It doesn't work, in my opinion. I don't get dizzy when I'm wearing the VR headset, but I get dizzy when I use the other movement things we've implemented. So we just went back to the teleportation, for instance.
Yeah, the cool thing they added, one of the cool little additions is slow-mo when you teleport. You guys did that, and it's totally awesome.
I think iteration is key for all of this stuff. It's just we go through so many things that fail.
For sure. Yeah, fail fast. That's a good motto. Yeah. Okay, we got about 9 minutes left. We'll kind of try and get through as many questions as we can.
I'll try to speak loudly so everybody can hear me. You had mentioned the extensibility of Vulkan. I have a G-Sync monitor, and I noticed that when I run Vulkan, it doesn't take advantage of the variable frame rate. I don't know any much back end of Vulkan API or how NVIDIA G-Sync works, but do you know if it's possible that it'll get it working in the future?
Yeah, there's some little tweaks we still have to make. There are some tweaks that have to be done on the driver's side as well. We're currently working through those issues, and there will be an update as soon as we have it ready.
Thanks for all your work.
So, thank you.
I appreciate it.
Thank you.
Make sure you.
I forgot to say, we'll try and repeat the question.
Oh, I'm sorry.
It's
I'll do
okay.
that.
It's okay. So, yeah, we've got a stream going, so we'll try and repeat the question when we answer it.
Hey folks, thanks for doing the panel. My question is, historically and traditionally, id Software has tried to, whenever possible, write as much of their engine in-house, trying to do all the solutions themselves. If you look at the source code from id Tech 1 all the way through id Tech 4, I mean, everything is done the id way rather than outsourcing it to a third party or something like that. I can't speak to id Tech 5 because obviously the source code isn't out there, but maybe you folks can speak to id Tech 6. Firing up Doom when the logos and the legal mumbo jumbo is coming out, one thing sticks out. Using Umbra for visibility. Maybe you can speak to that, what Umbra is used for in id Tech 6, why it chose to go with a third-party solution for visibility versus implementing it in-house as in previous engines.
I can speak specifically to the adoption of some additional third-party libraries. We also use WIs for audio, and these were very deliberate decisions. Effectively, from an audio perspective, WIs allow us to put most of the sound creation, well, all the sound creation obviously, but most of the sound design and problems that go along with maintaining an audio engine internally. We move all that work onto the sound designers, and they have a really good authoring tool, like world-class authoring tool that they can now build soundscapes with. And Umbra is used for occlusion, and we needed a solution that was fast enough. We wanted to remove a frame of latency from our occlusion system, and that was one of the primary reasons to go with Umbra. And there's still a lot of work on our side in both cases to get these integrated. But these were choices of really time and effort. We certainly have the people and the backgrounds to write a new occlusion system, but for a relatively low cost, we can integrate something third party. We can work with a partner and really get results much faster and really focus. Again, Doom is about the game design and about the player, and we really wanted to focus as much effort as we could on the game itself versus just necessarily owning the technology to own it. We're still probably 90% all pure id code. But we've made some what I consider to be intelligent choices on adopting certain third-party libraries.
All right,
Cool.
thanks.
Thank you.
Hey, I was playing Doom last night, and I was just running around, jumping around, just being very weird in the game. I wasn't playing it like it's supposed to be played. Like a buddy of mine was looking over, he's like, "What are you doing?" I'm like, "I'm just enjoying the engine." I love the id Tech engine. I love it. It's a masterpiece, and it feels great to play. That said, when are we going to be able to just jump direct, like launch Doom into multiplayer? Is that possible? Do we have to jump into the main console and switch over to multiplayer? And maybe if not, like, what's the story on that?
You want to take that again?
I can.
take a heat.
That was all me. The basic reasons on that particular choice on having to reboot the game into each mode is effectively was memory, largely memory driven, and we also wanted to stay the same on all platforms. Technically, it's technically possible for us on a PC to have all three modes available. It was going to be a good bit of additional work. For the future, we're going to probably do a shell that we'll load a DLL and things like that, because we're doing DLL separation and some other things for whatever we're going to work on next. But those were conscious choices, basically all centered on memory pressure, because SnapMap, as an example, has a much bigger memory footprint because you have to have the editor loaded, you have to have all the assets loaded, and some of those choices were just for that. So I don't like it either, but
Thank you.
Okay. So you guys have talked quite a bit about the benefits of Vulkan. I was wondering, historically, the GPU manufacturers have put a lot of effort into game-specific optimizations of their drivers, either fast paths for the way in which the games use the APIs, or optimizations to work around weaknesses or get benefits from newer architectures. Will they still have some of that freedom in Vulkan, or is it all on the game developers now to optimize their particular hardware?
There are still many things they can do on their end, because as you mentioned yourself. So the question was like, if we use Vulkan, will the IHV still be able to have custom drivers that will be offer optimizations for specific games? And the need for that is actually reduced, because the developer will have full control over stuff. And the need is reduced because we can tell the GPU exactly what needs to happen. So then, like Thiago mentioned, the way Thiago mentioned is like it's a smarter approach, because we don't have to replicate that same work every frame. But on the back end, some of the architectural choices that the hardware manufacturers are making, some of those are not accessible to us. So there will be some work on how they deal with memory, how they deal with their caches, how they move textures in and out, how they use some of their caches, for example. There is still some work that they can do, and it's quite significant actually, but again, Vulkan actually makes that easier for them, because they will know exactly what our intent is. And if they know the exact intent, then they can even do better optimizations. So going forward, I would say the drivers will be even better. So don't worry, you'll have plenty of good stuff to look forward to.
Thank you.
Hi. I actually also have like a two-part question about Vulkan. So the first part is, were there any new kind of technical issues or problems that came up with Vulkan versus what you're used to doing previously? And then second, the fact that you guys have more control over what the GPU is doing, taking away the learning curve, would you consider Vulkan to increase or decrease or make no difference in your development length of time?
I can talk about that. So the question was, like, will Vulkan increase our development time? And the second portion was like, is the learning curve part of it?
Well, like, were there any unique issues?
Oh, the unique issues, yes. Yes, we encountered lots of unique issues, and it usually came down with GPUs that had low memory consumption. And the way you have to handle memory in Vulkan is slightly different. We have to do the work on our end now, whereas with the driver used to do that. There is some learning curve there, but that's something you can overcome. There will be, the IHVs were very handy in providing solutions to help with their particular hardware, but rethinking the way you deal with textures and how you use textures is critical. I think in the long run it'll make our life easier because you won't have to worry actually about supporting so many different APIs. Ideally, some of the other partners we have will come to their senses and use Vulkan for their new platforms as well, especially as we want to maybe branch out and make another titles and all these new platforms are coming out. So I think in the long run, having Vulkan will actually just make our development cycle go down. Because we don't have that latency between like, oh, the driver broke, we have to fix this, driver broke, fix it. We actually have more control.
We'll make this last one quick, so thank you.
So with your rendering equation that you're using, are you using per fragment lighting across the board, and also are you using ambient occlusion filtering in it? Or ambient occlusion lighting?
So the question is about the lighting equation, what we are doing for the lighting in a sense.
That's
I mean, that's a huge topic. I'll try to summarize it a little bit. Okay, so the engine itself, it's an hybrid solution and of several lighting solutions of approximations of what runs fast for certain things. We try to keep it as unified as possible across different types of surfaces. So if it's an opaque surface, if it's a transparent surface, all of that goes through the exact same pipeline. And then there's certain types of, okay, we still are not able to do real-time global illumination super efficiently at 60 hertz.
I think it's next door.
This making some weird sounds.
I think they have a campfire.
So essentially we have to resort to pre-computing some of the data, of course. And that includes, for example, some of the reflections that you might see in the game. It's an hybrid again of, okay, we can pre-compute some of the reflection data that we have, but we can also merge it with the dynamic reflection so that you might see on the game. And I mean, this is the usual approach for several things. And then there's certain cases that if it runs super slow, of course you have to come up with something creative. So that was the particles solution, for example. That's about it. I mean, of course, we do some specular occlusion, some ambient occlusion, and all of that. It's kind of a requirement these days. If you are doing physical-based rendering, you cannot just have reflections everywhere and have everything looking super shiny. You have to do some. There's a lot of mathematical foundation. We spoke a little bit about this on CBRF. Not in super in-depth detail as I would have liked to, but there's some information there.
Thank you.
Cool. Well, thank you to our panelists, Robert, Shiel, Billy, and Tiago, and thank you so much for coming to QuakeCon and again coming to our panel today.
And thank you for playing Doom.
And buying Doom.
Yes.
Yeah, really appreciate it.